Good morning and welcome to today's webinar on our Blueye SDK. Today we also have with us a researcher from the University of Zagreb. His name is Nadir Kapetanović. He'll be joining us for the later half of the presentation to do a live demonstration of his work. I'll give you a proper introduction once we get there, Nadir. All right, so our SDK is a GitHub repository, which is open source and can be found on GitHub, Googling Blueye Robotics and SDK. As you see, it's well documented and easy to get started on, like you see on the right side here. So this is an example on how you can control the drone. So it's basically a Python package that you import. And once you instantiate the class, you get this drone object. You can change the lights like you see in the GIF here. So this is how you can also download all your videos from the drone directly with your own code in Python. So it's basically just connecting to the drone via the IP address on the port 5050, and there we have a WebDAV client who lists all the videos and files, and then you can of course you could list them out, or you could download them automatically, or yeah, interface it to your application as you need. We also have a GStreamer example that enables you to connect to the stream of the drone directly. And it has really low playback latency. It's about 200 milliseconds, and this enables you to integrate the video stream directly into ROS or into some other Linux or Mac system, also Windows, of course. So that's how you can tap into the video stream and record it directly or stream it further. We also have this Blueye HTTP API, which is mainly for retrieving pictures, overlay data. It could be CSV files pre-made for 3D applications such as Pix4D or Agisoft. So then you can get the IMU data directly synced with the video, and easier to work with in these 3D softwares. Yeah, so it's a basic HTTP API that you can do like a request response, and then you get either pictures or log files. So here's an example on how you can you could either use our Blueye app to download the dive log directly from the app. So then you would start by going to the dive log tab on the lower left in the app. If you're familiar with the app, you will know this. And then you find the correct dive and you click download or the share button to the upper right, and you'll find either auto-generate the PDF, a Word file, or you can also download the CSV file directly. So once you have the CSV file, you can continue the post-processing in Excel or read it into Python and Pandas and continue plotting there. The alternative is to access these files directly via the API, and then you would typically do a GET request directly towards the drone. So you see the IP address of the drone /log CSV, and that will list out a JSON response with all the files on the drone. So that's also a way to have a systematic way of downloading data. And of course, you can build on this to have automated fault detection or outliers, or if there are any things you want to do systematically with your log files. All right, so now I'm going to tell you a little bit about why we created this SDK, and it really started with the university here in Trondheim called NTNU, which is also been following us for a long time, and they wanted to be able to control the drones with their own code, because they had this project where they wanted to combine 2 drones into one larger ROV, so they could carry this ecotone hyperspectral camera. So you see it in the left picture there. It's quite a beefy sensor, which is basically a hardcore camera that can see a lot more than conventional cameras, because it can see the different signatures of different material at the seabed. So they needed a way to control the drones directly. So you could, as you see, when you combine 2 drones like this, you cannot control them with our app, because then you would have to have 2 operators driving in parallel in a way, and be coordinated in if you want to go forward or go to the left or right. So then they wanted us to create this SDK so they could have an interface to program against and make up their own Python programs that would make a new trust allocation. So when you have a joystick telling the coupled or twin drone to go forward, it will recalculate what trust to give to which drone. And if you want to go left, you have to go forward with the right drone and backwards with the left drone. So, and this was a great success for them, because they could carry this heavy sonar, camera, with a much cheaper vehicle than the conventional larger ROVs. So the professor who was in charge of this project, Asger Sørensen, he claimed that it's about 10 times cheaper, this setup, than bringing a full-size ROV to large enough to carry the same sensor. And here are some of the results. The research project was actually carried out at the Svalbard, or Spitsbergen. So it's very far north. It's also a part of Norway. And as you see in the lower left picture, they are diving under the ice to do some research on what type of algae are present at the sea bottom there. So as you see, it might be a little bit small text on the right graph there, but it consists of, you could see the different signatures from the red algae and the brown algae and the minerals on the right graph. So then they could do large surveys under the ice and really map out what type of material it is, not just what it looks like, but because of the signature, they can also see what it is, what type of algae it is. And the next picture is showing basically how their control flow is. So it's the human operator who has a control input to their topside laptop, and then there's a Python program redistributing the control signal to these 2 instances of the pioneers, or the drone class, which I showed you in the previous slide. So if you go back, you can see this is basically what the program is doing. It's instantiating 2 drones, and then it will have the thrust allocation in between to reallocate the motions for each drone. So when you see the p.motion.surge 0.3, then you get like 0.3 force going forward. All right, and yeah, the last one is the thrust allocation used in the paper that they published on this. Another example of someone who has used our SDK is Roberto Gonzalez from Horizonte. They are creating this software called Aquacore. The software is basically a vessel traffic system, tracking system that it's monitoring the river information and traffic in especially canals in Europe. So if there's an incident happening, you could see also how the vessels had been moving prior to the accident, and you could also integrate lots of different sensors and radars and yeah, weather forecast, etc. So they have actually used our SDK to be able to display videos or recordings from the drone that are taken at different locations. So then you would see how they pop up in the map, and on the drop down there you see the typical file names of the video files from the Blueye drone. So then it's also possible to preview the video directly in this software. You can also see the at the lower part there, it's like a zoomed in on the options in the header bar. So they have like the Blueye import button, so you can import from the drone, or you could stream live video from the drone directly in this software. And they also have their own streaming service, which is the CCTV stream. So it's a way of capturing more data of how is the seabed looking right now in these rivers, and typically around harbors. The seabed can be changing quite frequently because of currents and changing conditions. So it's, for them, it's beneficial to be able to share pictures of this status quite frequently in terms of what it actually looks like at the seabed in certain areas. So they used our SDK to download the videos, like I showed here. So it's basically connecting to the WebDAV server and pulling those out. And you could also use the log file to get the GPS position of where the user was when he conducted the dive. So by combining those, they could put the videos with the location on the map. And then I will leave it over to Nadir Kapetanović, who's a researcher at the University of Zagreb.
I'll be talking a bit about integrating the Blueye SDK with the newest ROS2 Foxy, which would enable us and all the others research groups to easily plug and play Blueye into the newest version of ROS2, as I mentioned, and then to perform any kind of research with it. So on a general note, we acquired the Blueye ROV, the Pro version for our Hector project, which is a project with containing like a heterogeneous swarm of robots, be they drones, all-terrain mobile vehicles for inspecting and cutting grass in viniculture, or the autonomous surface vehicle together with the unmanned aerial vehicle and the Blueye ROV for inspecting the in aquaculture or possibly many other applications. So here to the right is the scheme for the aquaculture surveillance and inspection. So the idea is for the flying drone to inspect, of course, from the air, see if there are any anomalies of the fish cage. Are the fish being fed, and what's the biomass estimated in the cage itself, and then to coordinately fly off of and land onto an autonomous catamaran, which also has a tether, or should have, as we will design it during the course of this project, like the tether management system for the Blueye ROV, since there are no small-scale tether management systems as we've searched throughout the market worldwide. So there are many components to this project, and actually one of the tasks which I'm mostly involved with is actually the ROV and the integration with the catamaran. So as for the catamaran, this is our autonomous surface vehicle Korkira, shown to the right from the basic concept to the first version, and then to the model at last. It is a 2 meter by 1 meter aluminum catamaran, which basically without any payload weighs about 50 kilos. Now it weighs like 110 kilos, and it can go up to even 30 or 40 kilos more of additional payload. It uses 4 T200 thrusters for steering mostly, or fine-tuned, for example, dynamic positioning or slowly moving around the fishnet cages in aquaculture, as well as Minkota much higher power boost motor, for example, for sonar, bathymetry sonar, survey missions, or like further away waypoints reaching. It represents actually the continuity of the autonomous surface vehicles design in our laboratory, the laboratory for autonomous or underwater systems and technology here at the University of Zagreb, which was previously named APED, and it was actually the top side, the carbon hull from the APED was basically transplanted with all the intelligence inside, so to speak, and the electronics onto the new catamaran hull for this Hector project. Furthermore, the catamaran has like a top and bottom deck for additional payloads, batteries, etc. It can reach 3 to 4 knots and have an autonomy of upwards of 4 hours, since we can load many more batteries onto it. As for payloads, it has an orbit multi-beam sonar, the WBMS one, the ROV, the Blueye, and the tether management system, which will be designed, and also which I mentioned previously, the platform, the landing platform for the UAV on top of the catamaran. So as for the Blueye ROV, we acquired the Pro version, which goes to depths up to 1,000 feet, or approximately 300 meters. It has autonomy of 2 hours, which for aquaculture inspection missions is quite enough for us. The mass of 9 kilos in air, if I'm not mistaken, which is quite good, since it doesn't add up additionally to the payload mass of the catamaran. It has a maximum speed of 3 knots, and it can operate in conditions of maximum sea current of 2 knots by its datasheet. What is good additionally is that it has a full HD camera with tilt mechanism, which is not that often found at the market, and also the lights, which are quite strong and good for color calibration and truthfulness, so to say. It has also very high quality of maneuverability with auto heading and auto depth control, and comes, I believe, with the default 75-meter tether, but since it goes to 300 meters depth, we also bought a custom-made 400-meter long tether. For the controllability and maneuverability, of the Blueye ROV, I can only say that it's really good, and it feels quite intuitive, so to speak. It's not jumpy. Also, you can change the gains, the gain boost. So if you need like precise operation, then you can slow it down. What was actually the most important specific of the Blueye was actually this SDK, since it was aligned with our plans during Hector project, and basically there were no other ROV producing companies which offer this, especially open source SDKs. They didn't have SDKs, as I recall, at all. So it was all pretty much proprietary, and any kind of autonomization of the ROV, which we need in Hector project for any commands to be sent from the surface vehicle to the ROV, and then streaming the video and processing it in the closed loop aboard the autonomous surface vehicle, wasn't basically manageable by any other ROV, small scale or large scale, which we couldn't afford, to be honest. So yeah, this was actually one of the main things why we bought Blueye, except for like high quality production, of course, and very good maneuverability. Here are some examples of our use of Blueye at sea. So this is at Kromaris fishery at one of the islands here in Croatia last October. So we tested Blueye and Blueye Robotics as well. And to be honest, Blueye was much better maneuverable and with the better lights and camera. So comparing at least those two ROVs which we have here at the lab, the Blueye actually performed much better. So here are some examples of the inspection of the biofouling of the fish nets with the Blueye camera, and as well with the forward-looking sonar, which was used alongside the ROV, but not connected to the ROV, since it would be too heavy a payload. So here is the schematics of the integration of the SDK provided by Blueye and ROS2, which we use for research. To the left, you can see the GUI, which was developed for these purposes, and you can see to the right are basically copy-pasted the functionalities of the application, the phone app, which Blueye provides for controlling the ROV. Here, there are states like batteries, auto depth, auto heading control, also changing all the parameters of the camera, as well as boost gain down to the right. And the schematics at the right show actually the ROS2, the whole framework, actually, the nodes and the topics through which each process actually communicates and exchanges either controls or feeds back or streams the video back to catamaran or topside, whichever that is. So we have a topside here and bottom side. So the topside is basically operator PC, for example, my laptop here at the shore, and the bottom side is actually the Intel NUC mini PC aboard the Korkira catamaran. So you see that this node, Blueye ROS2 interface node, actually communicates directly over by using the Blueye SDK with Blueye, and then it reads out all the values and sends the commands directly to Blueye ROV, and that's it for the schematics part. Also, here's the example of yesterday's testing of the Blueye ROV to ROS2 integration here at Split, Croatia, since we're having finally like the second trials in the past 2 years. And to the left, you can see in the middle the catamaran, and in the left part is the white Blueye ROV, and to the right you can see the overlap of the GUI from from the ROV, and up to the right you can see the feed from the IP camera of the catamaran. Okay, so I can share my, or actually remain in screen share, just to show. Do you see my screen still?
Yes.
Okay, great. So here, upwards to the right, you can see the live feed from the IP, the surveillance camera aboard the catamaran, and as you can see, there's a Blueye there in front of the catamaran. Okay, and then here downwards, you can see the feed from Blueye's camera. To the right, you can see the battery state. You can change, for example, the exposure time as in the app, or make it in auto mode. Also change white balance accordingly, hue as given. So all these functionalities have been actually basically made to be one-on-one copy from the app, and developed just for in RQT GUI for us. You can change also the bitrate of the video, which I think that basically, but BRR you wouldn't see on the screen. Also change the frame rate, so we're minimizing that to have minimum congestion over our local Wi-Fi, because the whole lab is using many other marine vehicles. Also change, for example, the resolution, and also turn on the lights, for example, which if I turn the ROV, you can see now are turned on, or of course when I control them to 0%, they should be off now. Okay. Also, you can change the water density to salty, freshwater, and brackish, which are preset by Blueye SDK, or you can also manually type in this text box the values if the measured values are different, are any different from the preset ones. So basically, this is it from me. If maybe in the discussion part, the other guests can ask questions, as well as you, Andreas. So.
Yeah, thank you so much for this great presentation.
Sure, it's been a pleasure.
Very fun to see how you have been able to basically replicate our Blueye app in ROS 2, and as I understood it, you will also be opening this repository so more people can utilize this ROS node in the future.
Very important, and I forgot to mention it, unfortunately. So yeah, the idea is to make our, for now, a private Git repository, to make it public by, I don't know, by the start of May, I think was the plan. So anyway, yeah, the idea is, if we had this effort to develop this integration, then for all other research laboratories, that they can use this quite easily, and then plug and play their Blueyes into ROS 2.
Very good. Have you done any integration towards controlling the drone, or is it mostly interfacing it and the camera as of now?
So for now, the idea was to actually make this basic integration, and then in the following months, hopefully until September, we'll be able to like develop some control algorithms which would run aboard the catamaran, and which would actually replace the gamepad which I'm using now to control the ROV. So because the idea is, if I forgot to mention in for the Hector project, for the catamaran and the ROV to cooperatively and completely autonomously inspect the fish cages, together with, of course, the unmanned aerial vehicles. But this part with the surface vehicle and the ROV, I believe, is more interesting for the guests of this webinar.
Very good. Could you say something more about why you chose the Blueye drone and how you found us?
Yeah, sure. I mean, we've had many years of contact with Blueye, and they were actually guests to our Breaking the Surface yearly marine robotics applications and theory workshop here in Croatia at Biograd na Moru. So yeah, we made that connection with the company, which was actually a spin-off from the NTNU, if I'm correct.
Yes.
Right. So there's actually many years of knowing each other in a way. So we had like first tests of Blueye a few years ago when your company came to Biograd, and then when we searched for the ROV, which would be most useful for Hector project, then we actually searched basically first the Blueye, and then also, I don't know, other companies, Deep Tracker and Saab and others, but others were much more, had a much higher price tag, and also which wouldn't be as big of a problem if they had maybe an SDK. But when we contacted them and wanted to get like a quote, literally we asked, okay, explicitly, do you have an SDK, because that's crucial to us acquiring the ROV, because if you know, if we bought the ROV which doesn't have an SDK, then that would be a great problem. Sorry, do you hear me? Because
yeah.
So yeah, the SDK actually was was the main specification which alongside, as I said, the quality of production, etc., which was the reason why we bought it.
By the way, would it be possible to stop the screen sharing and use the camera instead?
Sure. Yeah. Sorry. Sure.
Oh, there. Perfect.
Okay. Here. So hello from Split. I'm not sure if I'm in the shadows. So here we are. This week we're here doing the trials for several of our projects, and it's been it's been quite challenging. But I'm happy that yesterday actually our catamaran had her actually maiden voyage together with the ROV. So all of this is quite fresh, and the integration of the ROV into ROS was made like in the last couple of months. So it's all in the beginning, so to say, being developed, and until the 2023, which is the end of the Hector project, I hope. I mean, we will have the whole system running autonomously.
Nice. And have you started like thinking about how to integrate the drone with the catamaran, like physically, and the launch and recovery and stuff?
Yeah, the launch and recovery part is designed by our mechanical engineers and us as electrical engineers for the controls of the servo motors. For so the idea is to make like a small scale tether management system for our 400 meters tether, okay, and make it like a single solution, together with the drum onto which the tether is placed, and the motor which controls how much tension there is on the cable, or at least what's the length of the tether which is being led to the ROV, and also that functionality we will for that functionality to work, and also for the localization of the ROV itself to perform the inspection of the fish cages autonomously. It will have it must have the underwater acoustics localization. So that's also one of the functionalities which we're looking into, to have a completely complete system with, for example, batteries for the acoustical beacon on the ROV, and then to ping it from the surface, whether it's USBL or even preferably SBL, since the catamaran is big enough for having even a larger baseline, and then to know where the ROV is for sending the commands to the ROV for inspection, but also to the tether management system to know how much a cable to let in or reduce the length of the cable.
Very nice. Yeah, we're also about to release a new product which will enable guest ports. So I imagine, I think you're muted, or I couldn't hear you right now.
Yeah. Do you hear me now?
Yeah.
Okay. Which will enable what? I missed that. Sorry.
It will add 3 guest ports, so you could add like a DVL or a positioning system or extra lights, extra sensors, O2 measurements, for instance, if you're doing fish cage inspection. So that could also be something to consider into the project, of course. And also together with the SDK, capturing other sensor data will be more relevant in terms of post-processing, and make sure that you treat the data and check for outliers, etc.
Sure. Yeah, because for now it has like a compass and IMU in a way. Yes. Because when we try to 3D reconstruct, very optimistically, we try to reconstruct the nets in Photoscan, but yeah, failed miserably because the environment is really complex and the lighting conditions are really bad and everything is moving around. Yeah. But nonetheless, yeah, we use the pose, the orientation estimation from the ROV as exported from like CSV format, to import that into Photoscan, and then to try to help the image alignment algorithms for the first step of 3D reconstruction. But yeah, that didn't quite help. But yeah, nonetheless, the ROV, yeah, as it has depth and heading control, it must have a sensor which tells it, of course, where it's headed. So.
Have you checked out the Agisoft or Pix4D?
Yeah, we have experience in our lab only with the Agisoft Metashape, as it's renamed now quite recently, and with Pix4D I think not, but our colleagues from other labs which use, for example, drones, DJI ones, etc. I think that they use that software, so maybe we can try. But yeah, nonetheless, in the problem with the 3D reconstruction of the fishnets in aquaculture is that everything is it's a moving target, you know. So it's nothing is static, and you have a fish which the drone sees inside and outside the cage. Yeah. And there's also the caustics effects from the sun being going through the waters and then being broken by the waves. So near the surface, at least for up to depths of like 5 meters, it's I think like complete chaos to be reconstructed, because it's too dynamic of a scene, at least for now. So we're also in contact with some universities in Italy which are really like researching into the topic of photogrammetry, and they find this problem also very interesting. So maybe, yeah, maybe something spans out of that as well. So
yeah, that's very interesting topic. I'm sure you have seen some of the work we have done on 3D scannings, and we have these tutorials, etc. But I understand that it's a very difficult environment when everything is moving and it looks very similar. The net is not changing much.
Yeah, sure.
So the sunlight is changing in every frame. So that will be, and it's also a large structure. If you were to scan at least the fish pens here in Norway, they are probably 200 meters around around the ring. So that would take a lot of processing to get the whole thing, at least.
Yeah, indeed. But yeah, the fish cages here at Kromaris in Croatia are, I think the radius is like 30 meters, if I recall correctly. So they're much smaller, but yeah, the same problem remains. I mean, you can divide and conquer the data set to like 3D reconstruct parts of it,
Yeah.
and then to sorry, merge like models of the complete 3D model. But yeah, I think that the main problem is more the lighting and stuff moving around than the size of the model itself. Because I mean, we have experience with, for example, in other Bluemed projects, we had to reconstruct like a whole islet in Greece, and we did it like with a few flyovers with DJI drone, and then a few days of processing in Photoskin. So it was just like brute forcing the whole data set, which was okay from the start, and it was like static and usable. So yeah, here it's completely another set of problems and difficulties which we face.
Yeah. All right. Do we have any questions from the participants, or feel free to add both in chat or the question application here? If not, I think we are, can give you some more time, but I think we are getting close to the scheduled time. Do you have any questions for me, Nadir?
No, I think that at least for now, I've reached back to Henry and you for any questions that I was interested in, and got the replies quite fast. So I mean, if anything pops up, yeah, I'm sure I'll contact you.
That's very good, and we will continue with updates both in the SDK and our own apps, and of course also on the Bluenux system, which is our own Linux version running on the drone. It's called Bluenux. So there's always new functionality coming piece by piece.
Yeah. Okay. Also, it just popped into my mind. The guest ports, will it be able to? Are you going to integrate completely the sensors into with the ROV, so to speak, or will it be like standalone units with the power and everything being logged like locally, and then when you pop out the...
Depends. We'll do a bit of both. We'll do some sensors we'll start integrating first, and then other sensors are maybe it's connected to Ethernet directly, so it's on the network, and then you typically use the software from the provider directly. So if there's a 3D sonar, for instance, it's faster to just use the software coming with that product. But for grippers or lights, etc., the extra camera, all those will be tightly integrated into the Blueye system, so it's just as user-friendly as the rest of the drone. And of course, merging the data with the main log file is also quite key in terms of merging the timestamps and knowing the position and the depth of let's say an O2 or some kind of measurement, so you don't have to do the stitching afterwards.
Yeah, and also it would be useful maybe for any kind of inspection to, whether it's like marinas inspection, aquaculture, I don't know, offshore wind turbines or whatever, to have like paired lasers for distance estimation. So at least for us, for any kind of visual surveying will be hard to impossible. So yeah, integrating lasers additionally would, especially if they're, that's why I asked, especially if they're completely integrated, so that the top side can get the data.
Yes.
That would, yeah, just as a remark. So that would be useful, I believe, for like a wider, not just us, but also for any, I don't know, research, I presume, communities and groups which would like to use the ROV for inspection purposes.
And of course, you could also, it's either lasers and you measure the distance between the lasers, or you could use hydroacoustics similar to the...
Yeah.
So at least if you can get a consistent measurement of the distance to what you're looking at, that's must be an important input to any computer vision algorithm, or capturing consistent data in terms of biofouling and stuff like that.
Because even now for us, that part of visual servoing will be one of the tasks for sure, because the ROV locally has to know how far away from the net it is, and to keep approximately like constant distance from the net in order to uniformly inspect the nets, right? So with just one camera, it will be it will be a miracle, but I mean, we're hopeful that either by adding lasers or as you said, like a simple basic echo sounder or whatever, that this will be greatly the problem will be decreased greatly.
And with the guest port, it also comes with the extra camera, so in theory you could sync those two to have stereo vision just by adding another camera with the same parameters and stuff.
Sure. I mean, another camera at least for estimating the depth of the field would that at least, right?
I see Hermant Ruda, he's impressed with your research and the outcome, and he's asking about if the catamaran has a basic DP capability.
Well, as I mentioned previously during the presentation, all the control navigation algorithms have been transplanted, so to speak, from our previous versions of it, much smaller ones, which had only that carbon hull, and that version is somewhere here being tested as well. So the DP functionality is there. So now what we have to do, since the configuration of the T200 thruster is in the X configuration, so it's fully controllable, right? And it's overactuated basically, so it can move omnidirectionally. It can DP, move sideways. So that's why we used T200s and left them at the catamaran as well. And then we plan to use the Minkota boost engine, for example, if starting waypoint is further away from the operator's base station, then it can just quite fast come to that first waypoint around, for example, aquaculture fish cages, and then to move around the fish cages just by using the T200 thrusters, much slower, but with higher maneuverability. Okay.
Yeah. So more for station keeping, and then you have the
basically
thruster for transport.
Yep.
That's probably an interesting task by its own, the path following and switching between transit and DP and all that. All right, I see our time is running out, and you probably have to continue with your field research.
Yep.
Yeah. I think we'll just say thanks for now, and thank you so much for joining, Nadir.
Okay.
It was
thank you for.
It's always more fun to see real stuff, and that you could also do the demonstration live. It's always a bit more real when it's live, right?
Yeah, it's like an added value of the presentation. So, and thank you for the offer and the given opportunity to present the results of our work.
Yeah. All right. Thank you very much.
Yep. Thank you. Bye bye.
Everyone. And of course, if any of you have any questions, don't hesitate to contact us either at contact@blueye.no or find me on LinkedIn, and I can help you out there. Thanks for joining, everyone.